Hello, everyone, and welcome to this webinar. We are really excited to have you here today to see there are many of you. So without further ado, I would like to go on with the presentations. So my name is Chiara De Grandis. I'm a sustainability consultant, and I also take care of communications together with Julia at GreenDelta. For those who don't know, GreenDelta is the developer of openLCA. And indeed, we also have Julia here with us. She's also a sustainability consultant, a researcher, and indeed, she also takes care of communications. So welcome, Julia. Then with us, we have Mohan. He's the founder and the technical lead of One Carbon Labs. One Carbon Labs is a partner of GreenDelta. And indeed, Mohan is also a certified openLCA trainer. So indeed, we really feel like this collaboration is really tight. So welcome, Mohan.
Thank you.
And last but not least, we also have Alok. So he is the technical advisor of One Carbon Labs, and he's also pursuing a PhD at the University of Bordeaux regarding integrated life cycle sustainability assessment. Hello, Alok, and welcome.
Thank you. Thank you.
Okay, let's jump into today's agenda. What are we talking about today? So first of all, we'll see what is LCA, what are the tools to perform LCA. So we'll go through both theory and a practical implementation. And then we'll ask ourselves why LCA, the big question. How is it important for the Indian context and what are the relevant standards there? Then we'll go through an industry example showcase in openLCA. We'll have a case study on green hydrogen production. Then we'll have an introduction on a new web tool, onlineLCA. And of course, we'll leave enough time for your questions through a Q&A session. So of course, feel free to write all of your questions in the Q&A section of the webinar. Okay, so now I will leave the floor to Julia.
Thank you very much, Chiara, for such a really nice presentation. Let me share my screen and let's get to it. All right, so you're seeing my screen?
Yes.
All right, so here I'm going to be presenting about, first of all, touch base on what's life cycle assessment, and then we're gonna go deep into seeing openLCA, just as a brief introduction. First of all, about GreenDelta. So I work for GreenDelta. We are based in Berlin, and we're the developers of the openLCA project. Okay, so this is what people usually know us for, but we are experts in the LCA field. We have global partners worldwide. So as Chiara said, we have One Carbon Labs based in India. That's our Indian partner. And we generally work worldwide, on different projects, both private but also public research. Yes. In our company, we have sustainability consultancy and research. We also have software development. We develop openLCA, but also other tools for sustainability. And also we develop databases and distribute databases. Yes.
Julia, sorry, we don't see like the presentation. We are still at the first slide. Maybe, yeah. Like maybe it's
now?
not the, like we see only the first slide, not in presentation mode.
Oh, okay, good. 1 second. I will just try again. Ah, yeah, this one. Yeah, super. So I was speaking about these slides before. Yes, everyone can see it now, Chiara?
Yeah. No, it works.
Can you see it switching?
Yeah.
Thanks for that. Yeah, so all that about GreenDelta, but let's then go to our first question. So what is life cycle assessment? Nowadays, it's very usual that legislation or just customers or the next person in your clients ask for sustainability assessments. Okay, so one big basis of this is life cycle assessment. And just as a touch base so that all of our audience is in the same ground, when we speak about life cycle assessment, we speak about a technique for assessing the environmental impacts that occur during all life cycle stages of a product's life. This can be from cradle to grave. And the ISO standards for this are 14040 and 14044, but on top of them, sometimes we have extra standards, okay? Like, for example, for environmental product declarations, we have 15804 standard, we have greenhouse gas protocol. It can also be for corporate accounting, etc. And well, openLCA, the software that we will present today, can be used for this. And then maybe more visual explanation. When we have something in front of us, it originated much further away from us. So in a life cycle, we have resource extraction and farming, processing, yeah, back in the mines, let's say. Then we have that this is distributed. We then have a manufacturing process, further transportation, and then it comes to retail and arrives to the user where we see the product, okay? Then we have that the product is disposed of, and this can be in different ways. One of them recycling, but it could also be that it's landfilled or incinerated. And throughout the life cycle, there are environmental impacts, okay? Both we take resources from the earth and we also emit emissions both to the air or to water, to soil, and this we quantify through life cycle assessment, okay? Brief example, let's look at the production of biodiesel. In order to produce biodiesel, first of all, we have some crops that are farmed, then we have some seeds, and there's an extraction process, the production of vegetable oil. This then has further production and refining to then arrive to the biodiesel. And then biodiesel itself, when it gets burned, produces some emissions. How you account for that depends on the standard you're following, because supposedly when you're looking at biofuels, the emissions of, let's say, carbon dioxide equivalent emissions previously when the plant was growing, they were being taken in. But that's a bit more detailed. This is an example of how a full life cycle would look. And then maybe next, let's look at tools for performing life cycle assessment. So in the market, there's several tools. There's quite some that have been available for the longer. And then we can also distinguish between tools that can do any life cycle. And then there's also some tools that are specific to specific products or fields, okay? Today, we're going to speak about openLCA, which is the tool that we develop at GreenDelta. It's an open source tool. It's the world's leading open source tool. It's been available and developed since 2007. This is some years after the other big players in the field. So openLCA came after, and it's a powerful, flexible, and available for free. This is part of how the project started, open source and available for free, and it is now, we would say, the most powerful tool for lifecycle assessment, and it's still available open source and for free. How could openLCA be developed with this business case, let's say, right, being available for free? So it was supported by the US EPA, Environmental Protection Agency, later engaged with Department of Agriculture of the US for projects. Generally, it has also been developed thanks to public funding in projects by the Joint Research Center of the European Commission, and so on and so forth. We're engaged in many projects through our consultancy also that help us spend effort in making openLCA better. And well, openLCA looks like a screenshot in to the right. It has really a lot of databases, and I'll speak about that later here. So the databases available for openLCA, they can be found in openLCA Nexus, and this is a marketplace for data. Let's say it's the Amazon for LCA databases. So there we can have quite some LCA databases like Equinvent, federal LCA Commons from the US. We have IDEMAT, Carbon Mines, IDEA from Japan, HiQLCD, new database from China, Agribalis for agricultural processes of France. There's really a lot of databases available. We have all of the databases, of the big LCA databases available for openLCA here, okay? And these databases, they're available for a price that's been put by the database providers. So we don't develop most of the databases, and these are third parties that then decide how much it costs, and you can then buy it through openLCA Nexus. That's where you would spend some money. That's what people maybe are interested in. So that's the case, okay? So openLCA is free, then data available is for a price, and yeah, then the extra cost would be then if you want to get training or support, that would be the extra cost, and I think that would be it. So the openLCA software can help you perform lifecycle assessment, lifecycle costing, social lifecycle assessment, but it can also help you. So these are big terms sometimes, and maybe people that are joining us today in this webinar want something less specific than or more specific than a lifecycle assessment. They want specifically only carbon footprint, yeah, or only water footprint. This is also fine. Lifecycle assessment is a technique that basically can do everything, and from there, applying specific databases or methods, you achieve a specific standard and result. So we have that with openLCA. You can also do carbon footprint. You can also do product environmental footprint, environmental product declarations. For example, the design for environmental label by the U.S. Environmental Protection Agency, or just generally integrated product policy. Yeah, it's depending on which standard you want to follow, you would use specific databases and methods with openLCA, following specific rules of that standard. Finally, maybe some customers from various areas. We really work with many fields and in many areas. So we have industry, we have institutions, and academy. Yeah, so public institutions and also academy. These are just some examples. From here, maybe that was a nice introduction from openLCA, and I pass my floor to Chiara for the next part of the presentation.
Thank you, Julia. Thank you very much. It was really interesting. I would also say a really nice introduction for what comes next. So I will leave the floor to Mohan that will lead us through the question, why LCA? Why is it important? How to tackle this question in the Indian context. So please, Mohan.
Thank you, Giora. Thanks, Julio, for giving brief introduction on LCA, GreenDelta, openLCA, and the capabilities of openLCA, what exactly we can do with openLCA. I start sharing my presentation. I hope it's visible, right?
Yeah, thank you. We can see it.
Thank you. So I'm Mohan. I have founded One Carbon Labs. I work as a technical lead here. So One Carbon Labs does consulting, training across all the sustainability assessments, focusing majorly on life cycle assessment and EPDs. Quickly, let's get into the slides. The section which I'm taking today is on why LCA, the Indian context, and then the standards. So LCA, there's a quite demand across the globe for the life cycle assessment, EPD space here. So let's see, whenever I speak about the sustainability with anyone, we always hear the commitments like net zero by 2030, greener supply chain, lower carbon products. So how to tackle these questions? Here comes the LCA, like life cycle assessment, give the what exactly we need to do to tackle the net zero, greener supply chains or the low carbon products. Okay, why this matters to India? So, so we are shifting from a consumer market towards a manufacturing hub for chemicals, textile, construction products. So buyers from European region, North American region, they are expecting the product level carbon footprint, life cycle assessments, EPDs. Uh, so whenever a producer uh, goes through an LCA or a EPD or a PCF, he will have a market advantage with respect to environmental footprint. So the global standards with respect to LCA, globally ISO 14044 sets the foundation for LCA. But depending upon the sectors, others like ISO 14067 for carbon footprint, EN 5804 for building products, and then PEF product environmental footprints come into play. So let's see the next slide. So whenever I sit with the uh, chief boards, executives of different kinds of sectors in India, I will be asked mainly a 3 to 4 questions. The first ones I come across is that what is the carbon footprint of the product they produce at their facility. So they always don't want the generic numbers. They want to know the exact CO2 associated with the uh, their products. Example is like whether they are producing steel or a chemical or any office furniture, anything. So because the buyers of these products are keenly interested to knowing the environmental footprints of their products. The second question I oftenly get to ask from them is that the hotspots, like, so where are the hotspots are coming from? Which supplier has more hotspots, like more emissions, or which process uh, has more emissions, or whether the emissions are coming driving from the um, raw materials or uh, supply chain or the electricity, like this. I always get the questions like this. So the third question is that the reduction strategies of the carbon footprint or any other environmental footprints. So how much can we realistically reduce? How quickly we can reduce? They need these answers. So what specifically drives the drivers for the Indian scenario? The first driver is that the compliance, the business responsibility and sustainability report (BRSR) is mandated for all the 1,000 listed companies in India, and then the extended producer responsibilities (EPR) for plastic, batteries, and electronics, and then the second comes the procurement and exports. The second driver is the procurement and exports. The global buyers increasingly demand product level uh, LCAs, EPDs in at the tender process only. And there's a great demand for this in European and North American region. And then the third driver is the finance and the investors. The financial banks and all the investor agencies are asking the production companies to go green at the higher level, whether it may be linked to ESG ratings or it may be linked to any other sustainability assessments. So let's understand uh, what exactly the difference between LCA, PCF, and the corporate carbon footprint. So LCA is most comprehensive. It deals with the complete different types of environmental impacts associated with the product or the process. It's not just only the climate change. For example, it can deal with the water usage, acidification, eutrophication, and there are like so many impact categories. So PCF, the main the standard related to LCA is 14044. And then when it comes to PCF, this is a narrow aspect of LCA, which mainly deals with the climate change aspect, which is expressed in the CO2 equivalence. So always buyers needs to know the carbon footprint of the product. So this has started at the tender level only nowadays. So the third one is the corporate carbon footprint based on ISO 14064 or GG protocol. Here, this is at the organization level where we calculate the emissions under scope 1, 2, 3. So this helps for the corporate to set their ESG disclosure, CDP, or science-based targets. So, like so many of you might have uh, some confusion regarding the standard to you for what type of the product or like what type of compliance or what type of regulations. Now, if we do an LCA, it's like how credible or that LCA will be accepted internationally. So the main core standard for the LCA is ISO 14044. So whatever the other standards related to LCA have been derived from here. ISO 1467 or mainly focuses on the climate change of a product, and then EN 150 for the construction, and then ISO 14025 for the EPD generation of the EPD. And then we have PEF guidelines from the European Commission, uh, and then reporting context, like even though LCA the LCA report majorly generated using the ISO 14044, the GST protocol and SBIT alignment can also be used for the reporting context. And then the tools, there are like various tools available across the globe. So openLCA and online or openLCA eco invent database can be used. So the main questions most of the time is that we get is that uh, what a good LCA looks like. So there are like many points to define the LCA as a good report or a good study. The first one is that you need to clearly define the functional unit and the system boundary, and that has to uh, carry the same alignment across the study until the study. And then establishment of robust data plan, prioritizing primary data with the secondary data, and then applying data quality across your study. And then whenever there is a multiple byproducts or the waste generated, like using cutoff systems, system expansion, allocation methods such as physical and economical allocations will really help. And then use of scenario analysis and then the sensitivity check to transform the results into actionable decision and the test of robustness. So always third-party verification or the independent verification from any LCA reviewer would enhances your LCA report, LCA study to gain the trust and transparency from your uh, customer. So what exactly the industry cares about with respect to LCA? So companies don't invest in LCA because they love standards or the database. They invest because they want to know the answers to drive the decisions. So the first one is that they always look for the hotspots. The first example, you assume that there's a 70% of footprint coming from a virgin resin or electricity or transport. Uh, how can you tackle that? And then the second thing comes as the reduction strategies. It's like if you show 2 or 3 reduction strategies and then percentage and the cost associated with the reduction strategies, this helps a lot. And then whatever the questions you want to get the data from the supplier, it should align. And then always have a single page document, a summary of your LCA study or LCA report, so that all the executives of your company will be able to understand in a concise way. So it is always difficult to read a 50-page or 100-page report every time. So what are the common pitfalls? So most of the times, the reports get rejected or go for many corrections from when we submit our report or study to a reviewer, third party, or independent. So what happens is that it's like the functional unit won't match the real case scenario. Like that's why it's like you need to really define your functional unit properly, and then use of uh, wrong data sets. Like assume that if you doing a project in India and then you use a electricity data set from European region, then it won't enhances your credibility of your study. And then in ignoring the end of life rules when it comes to EPD. So it's like when you do a EPD, it's like you need to take care of all the modules which are listed by your PCR. So and then whenever you do a study, LCA study, I always suggest you to give a multiple number. It's like one number won't define the entire context. Like so, you really need to do the sensitivity analysis, the uncertainty analysis in each scenario. So like this helps for the decision makers to take a good decision. So how you can implement a LCA study in your organization or in your academics or research? Like the first first 1 or 2 weeks, you majorly concentrate on scoping your study and then defining your functional unit. And then afterwards, once you start your preparation of question, you're correcting like secondary inventory data, you start with your basic modeling and analyzing your hotspot, identifying your hotspots. And then once you're thorough with this, it's like you can take some time to conduct the scenario studies and the interpretation of your results. And then if you require, you can carry out the eco design part or so call to action. Like so many of the organizations or individuals think that LCA will take so much time. It is more associated with the cost or this task will run for many months or years. So it's like at some point of time you need to start your studies. Like start with one product. Make sure that whatever you do is right and check with the experts in your circle on the product. And then once you are thorough and good with the one product, you can create use those templates to create different LCA studies for the similar kind of products, and then use the results in the procurement and design phases. And then you can scale your LCA studies using online LCA. So that will be taken later by Julia. So this is my um, uh, words why LCA and what standards we need to follow for us. Thank you. Like let's we move our thing to Kiara. Hi, Kiara.
Thank you very, very much. It was really interesting. I would almost call them guidelines for the implementation of LCA in the Indian context. So now we know what we have to take into account, what can be the next steps. So thank you indeed, Mohan. So now we can deep dive into an industry example. So I will leave the floor to Alok. I think you're on mute. Sorry.
Sorry.
Yes.
Yeah, thanks, Kiara. Thanks, Kiara. Thanks, Yulia, and thanks, Mohan, for the introduction and setting up the stage. I'll share my screen. Uh, Yeah, I hope it's visible at your end.
It
Kiara, can you
is, yeah.
confirm? Oh, okay. So yeah, I'm Alok Prasad. I'm currently pursuing PhD at University of Bordeaux with a focus on integrated life cycle sustainability assessment, and I'm also a part of One Carbon Labs as a technical advisor. So without taking much time, I'll deep dive into the case study that we have selected on green hydrogen production and its climate impact. This example helps us understand how LCA can be applied to such technologies and how tools like openLCA make the analysis transparent, structured, and reproducible. So yeah, why green hydrogen? So hydrogen is widely considered as a key enabler for decarbonization, especially in hard to abate sectors like steel, cement, or whether it's refining or fertilizers or transport. And for India, green hydrogen is strategic priority under National Green Hydrogen Mission, which targets 5 million tons of green hydrogen per year by 2030. So we have tried to showcase a generic example to demonstrate how LCA can be applied using openLCA and to provide a structured case that participants can learn from. So the focus would be on the PM electrolysis, which is powered by the grid, and we have added scenarios for the renewable electricity as well, which uses Indian grid and renewable scenarios to highlight the differences in the carbon intensity, and it is basically designed to align with the green hydrogen certification India requirements, which specify thresholds for the carbon intensity. So moving ahead, the goal and scope. The LCA, as Yulia mentioned, follows ISO 14040/44 standards, which specify to define a goal and scope for a study. So the primary goal here is to assess the environmental impacts of producing hydrogen through PEM electrolysis powered by renewable electricity in Indian context. The result will be used for illustrating and training purposes in this webinar. Intended application could be for the companies looking to adopt green hydrogen and need credible data to prove the compliance. And if we talk about the policy context, so as I mentioned, India's National Green Hydrogen Mission has created a huge demand for hydrogen's LCA certification is mandatory for export and domestic subsidies. If we talk about the scope, as Mohan highlighted, the use of defining a functional unit, a proper functional unit for the case study. So the functional unit that we have selected is 1 kilogram, producing 1 kilogram of hydrogen at the factory gate, which will act as a reference flow used for comparing all the scenarios. So this is basically illustrative case only. In real world scenario, we always need a third party critical review to authenticate our results and to claim it publicly. Moving ahead, we have the system boundary definition, which is very critical for the LCA. It clarifies which processes are included in the LCA and ensures transparency for interpreting the results. The system boundary that we have considered is cradle to gate, which includes electricity sourcing, water purification, electrolysis, compression, and auxiliary processes. We have excluded storage, distribution, and end of use since the focus is on production impacts. The geography is India to reflect the regional grid intensity. So the electricity is the most important parameter, I would say. We have considered multiple scenarios, which I will showcase in the later steps. The electrolyzer operations basically covers the stack operation, balance of plant and energy needs, and water inputs. Water treatment is being showcased to showcase per kg of hydrogen produced. And scenarios, we have considered multiple scenarios such as a baseline scenario, which I will show in the next slides. I'll talk about the scenarios in the later slides. So moving up from the system boundary to life cycle inventory. So life cycle inventory here, it's for producing 1 kg of hydrogen at 350 bar using a PEM electrolyzer. So all the inputs you see here, whether it's electricity, electrolyzer electricity, or the compression electricity, or the auxiliary electricity or the water input are all linked to the functional unit. Moving ahead, yeah, the baseline, as I mentioned previously, we have considered the electricity from the grid, which is equals to 62 kilowatt hour per kg of hydrogen produced, and water, which is 11 liter per kg of hydrogen produced. The scenario is 50% renewable mix, that is half the grid electricity is replaced, so the total is split between the grid and renewables, and 700 bar compression, and additional electricity per kg of hydrogen produced is required, raising the total electricity demand. And finally, the alkaline electrolyzer, where the electricity use is reduced as compared to the baseline, showing a higher efficiency compared to the PMs. We have a couple of another scenarios, which is the baseline one, where we have replaced the grid with the renewable energy, and again the compression one, where the demand uh, has risen due to the high pressure requirements, and the electrolyte and the alkaline electrolyzer, where the electricity is reduced again, showing the efficiency benefits. So moving ahead, yeah, so this is basically the layout of the openLCA modeling tool. On the left here, you can see the multiple scenarios that are defined. Maybe I can use multiple scenarios are defined: baseline, renewable, compression, and alkaline electrolyzer. At the top, you can see the inputs, which I just showcased in the form of a table as a LCI, which shows different types of electricity flows and deionized water flows. So these represent sources needed to produce the hydrogen, which is shown as the output. And each input flow is linked to a specific background data set. For example, um, if you see electricity high voltage is being linked to a background data sets, electricity high voltage production mix. And if we move forward, this is another snippet from the openLCA tool. At the top, you see a general setup. The reference is 1 kg of hydrogen produced, which is the functional unit. In the middle, openLCA is showing the impact method applied, yeah, which is the IPCC 2021. And at the bottom, you see the bar chart of top 5 contributors to the footprint. Here, if you see the coal-based and lignite-based electricity dominate, each adding several kilograms of CO2 per kilogram of hydrogen produced. Moving ahead, this is the impact analysis window, where the openLCA calculates the environmental indicators. The method that we have used here is IPCC 2021, and each rows represent a different category and corresponding results. For example, in baseline, if we see the global warming potential, excluding biogenic carbon, is showing up to 60.9 kilograms CO2 equivalents per kg of hydrogen produced. And then this shows the project level view. The advantage of openLCA is that all scenarios are handled in a single project environment. That means you can quickly test assumption, compare results, and ensure consistency across each scenarios. So each rows represents a product system that we have chosen so far, and here each category, each rows represents the impact assessment results, evaluating corresponding to different scenarios that we have considered. And finally, we have the results contributions on the bottom of the snippet. So if we talk about the actual, yeah, so here it's a report layout of the openLCA window. So it generates reports as well, and if we see the results over here, so each bar correspond to one scenario, and the selected indicator is again the climate change excluding biogenic CO2. And you can see the contrast. Grid electricity scenarios are very high, around 60 to 67 CO2, uh, kg CO2 per kilogram of hydrogen. If we talk about the results in depth, so first the electricity mix baseline, where the entire electricity was sourced from the grid, and the second scenario was 50% mix, and the third was the renewable 100% source from the renewable energy. So if we use only grid electricity, the emissions are about 61 kg CO2 equivalents per kg of hydrogen. With a 50-50, we can see a substantial reduction, and this drops to around 31 kg CO2 uh, equivalents per kg of hydrogen produced. And with 100% renewable electricity, the impact is just 1 point, around 1.3 kg CO2 equivalents, I think, which is below the threshold, which is around 2 kg CO2 equivalents. So this shows the electricity is by far the single biggest driver of the carbon footprint. Next comparison is the compression at 700 bar. So with grid electricity plus compression, emission rises from the baseline, and it is now 66.67 kg CO2 equivalents. But if we combine compression with the renewables, renewable energy, the impact is still only 1.4 kg CO2 equivalents. So the key point here is that the compression adds some emissions, but it is minor as compared to the electricity source. Finally, we have the electrolyzer technology. So with alkaline electrolyzer on grid electricity, we get about 55 kg CO2 equivalents. On renewables, this falls to just 1.15 kg CO2 equivalents. So while the choice of electrolyzer does make a difference, it is secondary compared to the electricity mix. And to be talk about the results and the hotspot, so grid electricity dominates with more than 90% of the footprint. Renewables are critical with 100% renewable energy emissions falls well below the threshold value, and a 50-50 grid mix still leaves emissions far too high. Compression, on the other hand, contributes marginally, but does not change the overall picture. And the alkaline, if we talk about the alkaline electrolyzers, are slightly better than PM on grid, but the difference is small compared to the electricity source. Moving ahead, yeah, so how does it align with the Indian context? So under the National Green Hydrogen Mission, India is targeting 5 million metric tons of green hydrogen annually by 2030, positioning itself as a global leader. For this work, certification is critical, and the Green Hydrogen Certification Initiative requires product carbon footprint disclosure, making LCA a mandatory part of market acceptance. And this is where openLCA plays a pivotal role, providing transparent, credible results can be trusted for certification and reporting. And finally, India's renewable energy advantage with abundant solar and wind gives it a unique cost edge, making green hydrogen both viable and competitive. So takeaways, the entire story is the electricity mix is the single biggest driver of the emissions, and renewables are essentials to keep the to stay below the threshold, and compression and auxiliaries matter less but still offer room for optimization. And finally, OpenLCA gives a transparent platform to test scenarios and align with policy needs. So I think that's it from my side, and I hand it over to Kiara for further.
Thank you very, very much. I think it's always useful to then see an actual case study after some theory. So now, since we only have 15 minutes, I would leave the floor to Julia to talk about onlineLCA.
Good. Maybe I can do it briefly so that we have enough time for questions. So we have seen how openLCA can be applied in a usual case study that you could do in openLCA. This is to be able to do this, you have to get trained on the software and, well, on lifecycle assessment. But we have now another tool meant for non-experts. And I want to leave it here so that you are aware of it. And if you're interested, then you can contact us if you're interested. Yeah. So we're gonna speak about something called onlineLCA. Do you see my slides changing
Yeah,
also?
yeah, we do. Thank you.
Good. So onlineLCA is a web tool. Okay, this is already different from openLCA because openLCA is a desktop application. Yeah, onlineLCA is a web tool. You get some login details and then you arrive to LCA models. Yeah, in a more user-friendly way. Maybe a bit the structure behind it is that we have openLCA as an engine, okay, with the models made by a professional expert user, and these models can then be accessed by non-expert users. Okay, so after logging in, we go in, and this is the home page. You have the options to the left, and then you have in the main place you can choose different models. In this case, we're looking at a project that is for photovoltaic farms. Okay, so you can either be accessing the photovoltaic farm model in Morocco, in this case, or you can be accessing literally the model of a PV module. Yeah, and we have even two examples here. So you choose a model, you open it, and here you are able to see things that you can also see in openLCA, but simpler. You can also change some things, but not all things, so that it's also simpler for the user. We see that you can change the functional unit, which would be here in amount. You can also maybe check the model, okay, and visualize it, but you cannot specifically change this model in its core, but rather you make changes of specific things that are available for you, okay? So we can change, in this case, for a PV module, those that are aware of solar panel modules, there's an encapsulant amount, there's an aluminum frame, a cell, the cell area overall, how much glass it has, and other components. You can be changing these, okay, here. So then you can run the model and calculate results. You're able to visualize results. This is for all LCA results. Yeah, so not only climate change or carbon footprint, but also other impact categories. However, this can be restricted only to carbon footprint if that's what your users will need or your team needs. You can then see the results more granularly, for example, through a Sankey diagram. Yeah, there's different ways of visualizing, but these are the two examples I've put in these slides. And also, I can even create a report. So yeah, you can download the report. The report can be set up to follow the template of your company, and that way, like helping sustainability accounting. Maybe a couple things more. One can run comparisons with onlineLCA also. So here you can be comparing one module with another module, and then you run the comparison. And also the platform counts with user management. So you can add new users, you can tell the users what models they have access to, what things they can see, how much results granularity they can see, etc. And this onlineLCA is already being used in Engine, some EU projects, namely Engine, Titoloop, and Kyoptipack. Yeah, so we changed also the user interface to look from the usual basic onlineLCA to look in the identity of the project. This is also something we can do, and we're also working with private clients. So if this is interesting to you, you can contact GreenDelta. Or if you're based in India and you want to speak with our Indian partners, you can contact Mohan. Yes, so this is my specific email address, or you can contact, yeah, GreenDelta. But from here, I leave it off to Chiara and to the questions, which is also very interesting.
Indeed, thank you, Julia. I think it looks really good. So indeed, if you're interested, let us know. We are here. And so let's get to the questions. There are many of them, so maybe we won't be able to tackle everything, but hopefully as much as we can. Okay. So let's get started. The first two questions are really similar, I think. So the first one is, how much is the acceptability of openLCA software compared to other LCA softwares? And what are the key advantages of conducting assessments with openLCA compared to other softwares, especially in terms of output quality, efficiency, and delivery? I leave maybe the word to Julia.
Yes. So openLCA software is an established software in the lifecycle assessment field, as established as CIMA-Pro or Gabi. It is a software that appeared later on. So CIMA-Pro and Gabi appeared before the 2000s, and openLCA has appeared afterwards. And yeah, it has really spread very widely thanks to users using it, other people interested, and the software being of really good quality. It's a professional LCA software, and it's used, you can check in scientific publications and really widely amongst industry and academia. And this is you can see this not only in this webinar, but rather taking a look at maybe LCA studies that are of interest to you, you will find very commonly that openLCA has been used. So it is very accepted and widely used. The advantages of using openLCA is that, well, I mean, what people think first is that it's a free and open source software, yes. openLCA is really good at data management, okay, data accessibility and compatibility. So we can import and export not only our format for our data format, but also ILCD data format for that's the EU established data format, environmental footprint data format. We can also import and export CIMA-Pro CSV data formats. And so, yeah, it's quite strong there. And also that it is, if you're into techy things or software development, you can connect to openLCA with an API to then, for example, we've made onlineLCA, but you could make another tool or things like that. You can use it with Python. So it can be very powerful if you want, and also can be used simply. We think that our user interface is also very fine to use, nice visuals, nice result representation. Yeah.
Thank you, Julia. And I would also add that we also have a nice network of information in case you want to study on your own. So we have our YouTube channel, we have case studies, we have the manual. So there are really a lot of ways to deep dive into openLCA, even through self-study. Then, which open source LCA database is available, or it is best or free? Because we had many different questions about this for the Indian context.
Maybe, Mohan, do you want to speak about your experience?
Yes. So it's like they are very limited data sets when it comes for the Indian context. Like EcoInvent has developed few data sets related to transportation, electricity, construction. So initially, a few years back, Navy started a project where to compile a Indian specific LCA data sets. I think it's still under progress. Yeah, like we don't have any updates from them. So when it comes to open source, there is no much data sets related to Indian scenario. So if we are into a industry using EcoInvent, I would prefer like whenever you have a data mismatch with respect to region specific, you can make necessary assumptions in your study. So as of now, for Indian condition, we have less data sets. So we hope so, like in future days, like the people work on that, create good Indian data sets, like so that we can use our region data sets to conduct the study.
Thank you very much. Yes, this was a very much asked question. For the next one, thank you for showing the case study. It will be really helpful if you show it from scratch, like a complete demonstration. Maybe I can also answer this, like, of course, to show the whole case study, it would probably be another whole webinar. But in case you're really interested to see how openLCA works, how you can create a case study from scratch, we also offer almost every Friday, one Friday yes, one Friday no, some demo sessions. You can find them in openLCA.org. So there we really show the software, we create a process from scratch. So if this is what you're interested in, you can also have a look there. And like I said, we also have some case studies in our website in case you want to take a look. So maybe this can also help you. Okay. Then, next questions. I've noticed that processes in the database are described as from cradle, including upstream activities such as diesel consumption, energy use, and associated emissions. In such cases, should be avoided manually adding additional flows like diesel or electricity, since these are already embedded the process inventory. Maybe, I don't know, Julia, if you want to jump in on this.
Let me read again.
Yep.
I mean, so the database, for example, depends on which database you're using, but I think this case it was used, Alok was using Equinvent. It already has included all of these diesel, energy use, etc. If you're making your own foreground process, you're making your own process for the data you've been collecting for your product. If there's diesel, you then include diesel, etc. And the for example, adding diesel is not the same as burning diesel. So only adding diesel will take into account upstream of diesel, but not burning it directly. Then you need another process. That's my answer.
Thank you, Julia. So
maybe I
this
can
is
go
also,
to the
yeah,
next one also.
yeah, indeed.
So Equinvent and Agribalis database, they're not available open access. Equinvent was never available open access. Well, it was available open access for specific countries academic license. Okay. Then Agribalis used to be open access, but not anymore. Why? Because Agribalis actually uses the Equinvent database in its background and has license restrictions nowadays implemented. And therefore, in order to so Agribalis doesn't cost any money, but the license is dependent on the Equinvent license. So to be able to access Agribalis nowadays, you need a valid Equinvent license. Yeah, that's the current situation.
Thank you very much. So I think we got to the end of this webinar. We really hope it was helpful. I would like to, of course, thank Mohan, Alok, and Julia because it was really, really interesting. I also hope for you that are listening now. I don't know if you want to share some last words.
Yeah,
Mohan.
sure, yeah, sure. Yeah, like, thank you for hosting this webinar. Like, if anyone has any more questions, like with respect to openLCA, how to conduct that process, you can reach out to us. We are here to help you guys. Thanks for joining.
Indeed, I think it was really interesting to put this webinar together, specifically bringing Indian LCA practitioners or people interested in sustainability assessments together. I think the outcome was really good and we had a lot of attention.
Again, thank you very much, everyone, for participating. Again, we remain available in case you had further questions. And so goodbye and have a nice rest of the week.
Thank you,
Thank
everyone.
you.
Good day.
Thank you,
Goodbye.
everyone. Goodbye.